Good day. For those of you who don't know me, my name is Douglas Harder, and in this topic we're going to look at the topics of optimizing a function of a real variable. So in this short talk, we're going to describe what will be covered in this next section, specifically the optimization of functions of a real variable. That is, finding extrema of such functions. We will describe the algorithms that will be covered. So for a differentiable function of one variable, it's much easier to define an extreme point. The derivative is 0, and additionally, the first non-zero derivative after that must be an even derivative. If it's not that, then it's actually a saddle point and not an extreme point. Now, whether or not a function is differentiable or not, you can always find a minimum, or at least try to find a minimum, by following the gradient. So for example, if you are at a point x0, you can check if the derivative, assuming it exists, is greater than 0, the minimum may be on the left. Otherwise, if the derivative is negative, then the minimum may be on the right. Alternatively, you can of course also just check the value of 2 points, and the lower of the two will indicate on which side of the other the minimum is likely to exist. Now, if a function is one of a real variable and it is differentiable, then the Taylor series also no longer has the second term. So consequently, in the vicinity of an extremum, f at x of that minimum plus h is going to be f at that point plus 1/2 the second derivative at some point psi times h squared. And the second derivative, if it is a minimum, must be positive. Now, we are going to look at a number of algorithms. We'll start with a step-by-step algorithm that simply walks towards a minimum. We'll then look at Newton's method applied to the derivative of a function. Next, we're going to instead go back to the golden section search, and then we will try successive parabolic interpolations. Finally, we'll look at the Brent-Dekker optimization method. Now, the relationship to what we've already done is as follows. The first one is essentially a bounding algorithm and therefore parallels the bisection method. The second parallels Newton's method, which used Taylor series. The third is an optimization of the first, and therefore once again is a bounding or bracketed algorithm. The fourth, successive parabolic interpolations. Yeah, that sounds a lot like using interpolating quadratic polynomials. The last is a hybrid of some of the previous algorithms that tries to account for each of their weaknesses. So following this topic, you now have an overview of the ideas that will be covered in this section. You have an understanding that we will be looking at 5 algorithms for optimizing a real valued function of a real variable. And as you may have noted, we're using the exact same tools that we described at the very start of the course. Here are the references, acknowledgements, the colophon, and a disclaimer. Cheers!